Hey everyone, today I'm here to show you how to create and set up a basic network device topology with NTP server, DHCP, VLANs, you know, inter-device connectivity. We're going to have end devices here like a PC, and we're going to have two IP phones just so that we can make sure that they can ring each other, and it's going to be pretty freaking sweet. So the reason I'm doing this is because I have a project here that I had to complete. The topology is basically the same, but I had to make a guide for that project and how to do what I'm going to show you how to do today. So I'm just going to follow with my guide that I made, and we're going to see if it works. One important thing to remember about this is a few things. Excuse me. 2811 router for the core router. This is very important because I haven't been able to figure out what other router models work with voice over IP. This is the only model of router in Packet Tracer that I've found that can use the telephony service command by default. I have no idea how to make any other routers do it, but that is the one that works for me, and it works with this topology. So we're just going to do it this way. We're going to keep it simple. Another important thing to remember is we're not going to actually cable the IP phones yet. We're not going to do it right away because we're going to manually configure the IP phones to register manually. So we're going to do it one at a time at the end, and it should work fine as long as you do it, one at a time and before anything, we're not plugging anything in until the end. So you'll see what I mean, but those are the two big things. This router here is going to act as the NTP server. I think it could just be any router. So yeah. With all that said, as you can see, hopefully you can see these little labels here. These are just where I'm plugging the things into each device and their ports. So yeah, pretty simple stuff. Let's just get started. So we're going to start on the router here, the core router. One important thing to remember is we're going to change the host name because the host name is important for keeping track of which device we're on. R1, I'm going to call this guy R1. Maybe I'll change the name up here, down here later, but for now, that's all we need to worry about. We're going to disable DNS lookup, enable some passwords here. And these passwords can be anything you want, by the way. I'm just using these because these are the ones that I used on the project, and they're very basic. So if normally this is not recommended, just a simple one-word password, but for now, it's fine, just to show for the sake of example. So that's complete on the router. That's the basic initial setup here with passwords and such so that we can remotely connect to it. Now we're going to go to the switch. We're going to name this S1. Same deal, basically the same. Disable DNS lookup. Whoops. Passwords. And enable logging synchronous just because that's just a quality of life thing that we want to have because why not, right? And if you don't know what that does, it basically allows when a what am I trying to say? A debug message pops up on the screen when a device has changed or ports have changed, port states. All those informational pop-ups will usually interrupt the line that you're typing on, but with logging sync, it actually just brings the command that you were typing in down to the next line so that you aren't interrupted in the middle of it. That's a very useful feature that I think everyone should use. So again, this is virtually the same exact thing on the switch as it was on the router, but now where we get into a little bit more detailed stuff is the VLANs that we're going to create. So yeah, we're just going to start by naming and creating the VLANs here. We're going to create a data VLAN, a management VLAN, and a voice VLAN. And again, these VLANs don't have to be 10, 11, and 15. They can be whatever ones you want, but I'm just doing it for the sake of example. It'll make it easier down the line when we start assigning IP addresses and stuff. And on the switch, next thing we have to do is enable this interface as a trunk port. So there we go. And another important thing to remember is we don't want to bring these ports up until we have them all assigned as the switch ports assigned. So yeah, remember that. And the rest of the ports are going to be access ports. So switch port mode access. And we're going to have all these ports access the data and voice VLANs. We don't want them to access the management port or the management VLAN because they're not management devices that are going to be connecting to this. Spanning tree port fast. That should give you that. Port fast should work. And we're going to exit. Now, if you want to, you can do a show run to ensure that these devices are working properly. It should be looking good as long as this says switch port mode trunk on the interface that's appropriate. And the rest of these should be accessed. Let me see. Maybe I messed something up here. It doesn't say VLAN 10. But we did just create VLAN 10, which is odd. Let's see. Let's do a show run again. Yep. Oh, I see what I did wrong here. Sorry, guys. This should be, so an important thing to remember when we're assigning these different types of VLANs is we actually have different types, obviously. So VLAN 15 is a voice VLAN, and you have to specify that when you're assigning these switch ports. So the mistake here that I made is instead of typing switch port voice VLAN, I typed switch port access VLAN 15, which makes this, all of these ports are now saying, hey, we're accessing VLAN 10 as our data VLAN, and it doesn't have a voice VLAN assigned. So now if we do a show run, we should see, okay, yes. Now all the access ports are saying, hey, our access VLAN is 10 and our voice VLAN is 15. So that's just an important thing to remember. So again, once again, I'll just show it. Switch port access, that's what we're going to use. Obviously, if we wanted them to be trunk ports, we could make them trunk, but voice is the one we needed to use for the voice VLAN. So that's just a thing to remember. Didn't mean to screw that up, but that's why we do these show runs. So just, all the more reason to do those. Now we're going to create the switch management interface. So we're going to do INT and VLAN 11, which will create the VLAN 11 interface. And we're going to assign it the IP address 10.11.0.2. And we're going to give it this subnet. And if you want to, you can just follow along here with these subnets. It should be fine. 10.11.0.1. That's the default gateway, which obviously we're going to make that the router's default. We're going to make that the router's address when we do that. Now we're going to go back to the router, and we're going to configure. There's a lot to type here, so just be ready. And I'm going kind of fast, so hopefully you can keep up. If you need to go back or whatever, feel free to. So now we're going to configure the sub interfaces for each VLAN on the router interface. Another important thing to remember is that we're going to create sub interfaces. We're not going to create, we're not going to assign an IP address to just one interface. So that's important to remember, and we're going to do that for each VLAN. And we're going to do encapsulation .1q and then the VLAN number. That is important. And we're going to add a description that just basically says, hey, this interface is for this VLAN. And now we're going to create an IP address. We're going to assign IP addresses to each of these interfaces. And you'll see again, we're going to do F0/0 because that's the interface that is connected to the switch. .11. encapsulation dot 1Q11 description management VLAN. IP address 10.11.0.1.255.255.255.0. .15.0.1.255.255.255.0 and exit. Now we're gonna activate the regular interface that is actually physically represented on the router, which is int f0/0, and we're gonna do a no shutdown so that all those ports come up, and now it's connected to the switch. And if we want to, once this gets done, once this turns green from amber, we're going to skip ahead a little bit. We're going to go back on the switch, and we're going to do a show interface switch port. And the important things to look for here are these, and let's double check. That should look, these are the things we want to look for and make sure that these match. .1Q operational negotiation of trunking is on. And on the FA02, that's connected to the PC here. We want to make sure that this is a static access. This has .1Q encapsulation. And the access mode VLAN is 10, which is the data. And as you can see again here, voice VLAN is 15. That's what we need to see. So we're going to skip past all this. Perfect, perfect, perfect. And now we're going to go back into the router. We're going to do and if you don't know, you can do a show. Normally what you'd have to do is on this mode here, on this, level of access, you would do a show, any kind of show command you'd want to do. But if you're in a config mode like this, you can do show, or you can add the command do before any command, and it'll allow you to do it without having to be on that level of access or that access line. So we're going to do a show IP interface brief, and you should see that, yep, this is up, this is up, this is up. They all have IPs, and yeah, that looks good. Now we're going to set up DHCP. This is a little bit of, very typing, a lot of typing, but we're just going to do it. We're going to exclude addresses, and we're going to create pools for the data and voice DHCP services. So as you can see, we're creating an excluded address range so that the range between 10.0.0.1 and 10.10.0.10 will not be assigned by DHCP, or they won't be leased by the DHCP services. DHCP pool data, and then again, data is just the name of the pool. It's not a type or anything. Default router is obviously the one that, the interface that we've assigned the IP address to. There we go. We've got that all configured. So that's the first data pool, DHCP data pool configured. And now we're going to do the voice stuff. Excluded address. You can also hit tab to finish a command if it knows what you're trying to type. If you've typed enough that it says, hey, I know what you're typing, and you hit tab, it should recognize. If not, it means either the command isn't there, or it doesn't exist on that level of access, or you typed it wrong. .15.0.1 network. Whoops. 10.15.0.0.255. There we go. So now, if that's all configured correctly, we should be able to lease a DHCP address to the PC. So we go into here, we go into desktop tab, and we hit IP configuration. By default, it should be static, but we're going to hit DHCP. And if this is right, it should give us a DHCP address in that config, or in that in that network. So yeah, or in that subnet, I should say. So you can see we're in the data VLAN subnet. So that's a .10, 10.10.0.11. So that's the first assignable address that can be used by the DHCP network. As we said before, the excluded addresses are .1 through .10. So yeah, and as you can also see, the default gateway is the router's subinterface for the VLAN, 10.0 or 10.10.0.1. So that's all well and good. That means we have DHCP set up now, and now we can move on to the next part. But before we do that, we're going to triple check. We're going to ping the management IP address, and hopefully this should work. It might not work right away, but it should work. Yep. There we go. We're getting a reply, which means that works. And we're going to ping the router IP address that is our default gateway. And yep, there we go. So now those work. We know that the PC can talk to both of those. And now we're going to move on to the next part, which is the network time protocol. So before we do any of the stuff on the network time protocol router, we're going to set a time on the first router, the core router, so to speak. I'm going to do the time right now. So it's 1:18 on December 7th, 2024. That way, there's other configuration things that you can do, but because we're using an older version of a router that doesn't support all these things, the simplest thing to do is just this. Just clock set this. And that is the most basic thing you can do to allow NTP to work. Or rather, to have the time set on the router, I should say. So now that we're on this router, we're going to name it, we're going to go into the config, and we're going to name it NTP server, just so we can keep track of everything and know which device we're on. And we're going to go into the interface that's connected to the router. So that would be, for me, G000. And we're going to do IP address 192.168.0.1. And that. And we're going to do a no shut, exit. And now we're going to set the clock on this guy to the same time. Not the same time, but the accurate time. 2024. There we go. And as well, we're also going to allow this to say, hey, we're the source of the NTP. So that command is NTP master, and then I just made it 4. I don't know how much of a difference it makes, but I think to have the highest level, you want to use 4. Now we're going to configure R1 to connect to the NTP router by assigning it its IP address and enabling the interface. So this, obviously, as you can see, is interface F01, and we're going to assign it 192.168.0.2. Perfect. And we're going to do a no shutdown, exit, and this, we're going to do a command NTP server 192.168.0.1. This, obviously, might be able to infer that this is saying, hey, my NTP server is this address, which this address, if you remember, is the IP address of this interface over here for the NTP server. So it's the G000. So now we can verify that. Another thing I would recommend doing, because this takes a while, and I'm not sure why, but it just does. What I would do, skip ahead a few minutes, just click ahead, and on packet tracer here, skip ahead. It should probably log you out if you have this configured correctly. And we're going to do some show commands. We're going to do show NTP associations, which means, hey, it says, hey, this is the server that we're using for the clock, for our internal clock. And we're going to do show NTP status. And it says clock is synchronized, stratum 5. The reference is 192.168.0.1. And there we go. And this will tell you other important things, but for the sake of this example, we just need to know that it says it recognizes this router and that address as the NTP server. Now that we're done with that, we're going to get to the last part here. And the last part is configuring the phones and stuff and doing that on the router. This is the trickiest part for me when I was creating this, just because, one, again, the router, it took me 40 minutes to figure out which router was, like, I tried all these different routers, and the ones that actually worked for me was, the 2811. So this is where a lot of the trial and error was done for me, and because this is an older version, an older model of a router with an older iOS, it can be a little finicky. So make sure you follow this part closely, and if anything happens and you're not able to change something, what I did is I kind of just deleted the router. I screwed up while I was actively doing this project, and what I had to do was delete the router. So, it's a lot of work, but as long as you do everything here perfectly fine, or exactly as I do, there should be no problems. So we're going to start in config on R1. We're going to do the command telephony service. I don't even know if that's how you say it, but we're going to do that. And we're going to do no auto reg, and we're going to do no auto reg ephone. So those commands will disable phones that are connected from automatically having, like, registering and having assignments automatically. Then we're going to do max ePhones 2. I found that because we're only using 2 ePhones, the max we're going to need is 2 anyways. And we're going to do max DN 2. And we're going to make the IP source address 10.15.0.1 because that's the IP address that we're using for the sub interface of the voice VLAN. And because this is on an older router, we're gonna have to amend this port 2000 part here because it won't work otherwise on this model. Oh, I forgot to add the dash. There we go. There are other things you can do here, but again, this is an older version of a router with an older iOS, so a lot of the things that we should be able to do by modern standards isn't possible here. So again, this is just the most boiled down, simplified version of what we can do here. So now we're going to create ePhone directory 1. That should make it up. And the number for this guy is going to be 3333. And then we're also going to do ePhone DN2. This will make a second one, and it's going to be, the number for it is going to be 4444. And again, by modern standards, this is super simple. Other things you can do is add a name, you can add a username and password, you can do all this stuff, but this is an older version of a router, so this is all we can really do. And it's the most basic thing that we need to do to make this work. Now that we have those created, what we're going to do, we're going to go into our first IP phone. And for some reason, you have to manually plug this in, but that way it'll be on. And now it shouldn't do anything right away, but once we connect it with the switch, we should get something on the router. So let's hit exit, and we're going to give it a minute. It should give us some things that are saying, hey, we need this phone's trying to register. So now we have to find out the MAC address of this phone. So what we're going to do, because it's attempting to register, we're going to say, hey, show us the attempted registrations. And as you can see, it gives us a MAC address. What we're going to do with this MAC address is we're going to copy it. We're going to copy this MAC address. Sorry, I'm like really trying to get this right here. We're going to copy this MAC address. We're going to go into, let's see. We're going to go into ephone1, which is not the same thing as what we did earlier, ephone-dn1. This is for this phone now. This is for ephone1. And now we're going to say, hey, we're in ephone1. The MAC address of this ephone is the MAC address we copied from that readout, that show command. Now we just hit enter. And this is a tricky part that kind of got me caught up when I was doing this project for the first time. Button 1.1, I can't give you exactly what this does, but essentially it says, from what I understand, is button 1, which is a button on the actual device itself. When you press that button, it'll ring a certain directory number. And that usually means, we created these DNs up here. DN1 is number 3333. DN2 is number 4444. So for the sake of example, we're just going to have we're going to have ephone. It's kind of hard to explain. I don't know the full extent of it, but for this to work, what we're going to do is make button 1:1. That's what we're going to type for ephone1. Then, now that's pretty much done. Now what we're going to do, I'm going to keep this on top. What we're going to do is turn on our second ephone, and we're going to plug it in. And it should say, hey, we're on now. We're looking for stuff. Configuring VLAN, blah, blah, blah. We're going to go in here, say connect it to the switch. And once again, when we speed it up, we should get some messages here saying, hey, we got a phone trying to register. Now, once again, do show ephone attempted registrations. And we got our MAC address. Perfect. Whoops. Yeah, this is why we need logging sync, because it will get in the way quickly, especially if you're trying to type commands. So we're going to go ephone2. ephone2 MAC address. Paste that MAC address. You can also find the MAC address of if you're in real life, you can find the MAC address on somewhere on the device, or you can do what I did. There's a few ways to do it, but for the sake of example, we're just doing it this way because we can't actually see the MAC address on the actual physical device. And once again, we're going to do button 1:1. Sorry, I think it's 1:2. Yeah, my bad. That was a typo. Don't do 1:1 for ephone2. Do 1:2. And it should say it's been registered. Now, the last thing we have to do, and you could have done this while we were in the middle of it, but just this is how I have it laid out. We're going to go back into ephone1, and we're going to register the type of phone that we have. This is a 7960 model for ephone1, and then ephone2 is the same. So we're going to do type 7960. And that should be it. Now all you have to do, go on your device GUI here. You should see, it might be very hard to see. I know this is so small, but you should get the current time and day. As you can see, hopefully you can see this says 12:07:24, and the time is 1:45 a.m. or whatever. I don't know, but that's what it says. And up here we have the number, the DN number, which is 3333. And we're going to leave this on top so we can see both of them at the same time. And yeah, this is perfect. The second one, same time, same day, and the extension is 4444. So now, if all is said and done and we did it right, we should be able to dial 4444. And yeah, there we go. As you can see, this light is flashing. We dialed 4444 from here, and it's ringing on the other side. And it says they're connected. And now, just for the, final check here, we're going to dial 3333, and boom. It's ringing. The light is flashing. You can pick up, and they're connected. So yeah, that is really the long and short of it. I know this is pretty long. It's probably about a half an hour long, but this is a cool thing, and I really put a lot of work into it. So I wanted to make sure that you guys, you know, uh, just I don't know. I just felt like posting this, and I thought it'd be fun to record it and show you guys what I do. So yeah, thanks for watching. We can save it. We can do whatever we want with it, but this should all be good. And if we want to, we can also telnet. I don't know why I'm doing this, but we can try it. 10.0 or 10.10.0.1. We can actually connect to the router here, and it asks us for a password, which means we're able to actually remotely connect into the router's interface, or we can remotely connect into the router now from our PC. So that's another thing that we set up here. I didn't really get into it, but yeah, it's pretty cool. Yeah, once again, as we said, we got an NTP server synchronizing the time between all these devices so that the phones know each other's time and everything. We have DHCP so that all these end devices get proper IP address assignments for their VLANs. And the switch works and it does its thing. It's there's a trunk port between these two, and yeah, hope that was fun to watch. I don't know if it will be, but this is just a small, very basic example of the kinds of things that I do. So yeah, I just wanted to prove to myself that this guide actually worked that I wrote out. So yeah, thanks for watching, and if you want to see more of it, maybe